What if I told you that Ferrari could have found the secret weapon that would not only put it back on top, but change the heart of a Formula One car forever? Ferrari did not make this decision in a vacuum. The 2025 season was an emotional and technical earthquake for the Maranello team. It was a year of accumulated frustrations, broken promises, and fans that were beginning to lose faith even in their most solid idols. Charles Leclerc and Lewis Hamilton, two of the most talented drivers on the grid, were unable to convert that combination of talent and experience into a single victory. The SF25, that car that on paper seemed to be the right evolution, ended up being a stagnant project, unable to compete consistently with McLaren, Mercedes, or even Red Bull in its grayest days. But what really pushed Ferrari over the edge wasn't track performance. It was something more internal, more invisible. The feeling that, no matter how hard we tried to evolve the current model, the ceiling had already been reached. The wind tunnels, the test benches, the simulations. Everything indicated that there was not enough room to catch up with the leaders if they continued on the same path. The SF25 had reached the end of its conceptual service life. Development was not only costly in resources, it was useless. Each improvement brought with it new compromises, new mistakes, new frustrations. Faced with that stagnation, Frédéric Vasseur made one of the most drastic decisions in the team's recent history. Starting in April 2025, Ferrari completely froze the development of its current car. There would be no more aerodynamic updates. No new packages would be introduced. Even track testing began to be minimal. All financial, human, and technological resources were redirected to Project 678, the SF26, a car that did not yet exist, but that already carried the entire weight of the future on its shoulders. The story of the steel in the SF26 engine could have ended up as one more anecdote in the cemetery of failed ideas in Formula One. And no matter how innovative the proposal was, during the first months of development the results did not justify the risk. The first versions of the steel cylinder heads suffered from thermal fatigue problems, microfractures and deformations that made them unusable for an engine that had to operate above 1000 degrees Celsius, for hundreds of kilometers, with no margin for error. Each bench test ended with cracked components, deviations in internal geometry, and power losses that demoralized even the most optimistic of the technical team. The situation became critical when Wolf Zimmermann and Lars Schmidt, the original architects of this concept, announced their departure from Ferrari in the middle of the development process. His destination, Audi, together with the former team director, Mattia Binotto. A migration of brains that set off all the alarms in Maranello. The technical void they left was enormous. And for a moment, within the paddock it was assumed that Ferrari would abandon the project. That they would return to the conservative option of aluminum cylinder heads to ensure reliability. But then something unexpected happened. The Austrian firm AVL, known for its experience in developing hybrid systems and advanced simulations, came to the rescue. AVL not only provided technical support, it became a strategic partner. They took the digital models and rebuilt them from scratch. They introduced state-of-the-art structural analysis tools used in the aerospace industry. They implemented multivariate thermodynamic modeling to predict how steel would behave not only under thermal loading, but also during prolonged cycles of intermittent mechanical stress. What they discovered was revealing. The fault was not in the idea, but in the execution. The type of steel originally chosen did not have the right composition. It was not prepared for the rapid thermal cycles of a Formula One engine. AVL then proposed an advanced alloy, designed specifically for this type of environment. A complex mixture that incorporated elements such as nickel, chromium, copper, and ceramic components in millimeter quantities, creating a metallic matrix with unique properties, high resistance to thermal deformation, excellent conductivity, and unprecedented dimensional stability. But that was not enough. Ferrari, together with AVL, took the project a step further by incorporating additive manufacturing techniques. They used industrial metal printers to create the cylinder heads layer by layer, allowing absolute control of the geometry and material distribution. This technique allowed them to reinforce the most critical areas, lighten the less exposed sections, and generate internal cooling channels that cannot be manufactured with traditional methods. Each SF26 cylinder head is, in practice, a unique, custom-made component, adjusted to the limit of the tolerances that physics allows. Management of the project passed to Enrico Galtieri, who had already led the engine department in previous years, but now had full control after recent departures. Together with Davide Mazzoni and Guido Di Palados, key figures in the technical renaissance of the Scuderia, they restructured the engine validation process. It was no longer just about making it work. Now they wanted it to be competitive. And they did it. In final testing in 2025, engines with steel cylinder heads showed not only long-term reliability, but thermal performance that exceeded any previous expectations. The project went from being an experimental risk to becoming the central axis of the entire SF26 philosophy. It was the symbol of a new Ferrari. One that was no longer looking just for safe solutions but for real innovations. And that, after years of technical stagnation, he was once again leading a conversation that was previously foreign to him. How to push the limits of what is possible in modern Formula One. This block not only represents a technical collaboration, it represents the point at which theory becomes reality, where science and engineering meet the ambition to regain glory. Ferrari didn't just save his idea, he raised her. And now the entire paddock watches in silence, waiting to find out if this alliance with AVL will become the factor that rewrites the destiny of the 2026 season. The use of steel cylinder heads on the SF26 is not just an isolated technical innovation. It is a frontal statement against the traditional limitations of engine design in Formula One. And its impact is not only measured in horsepower or tenths per lap. It is measured in how it reconfigures the relationship between thermal efficiency, reliability, and regulations. Because if there is one thing that characterizes the modern era of F1, it is the extremely rigid regulatory environment. Starting in 2026, the FIA will introduce a series of changes that seek to transform the category into a showcase of sustainability, energy efficiency, and technology applicable to the civil automotive industry. And this is where Ferrari's bet could become its ace up its sleeve, or its biggest downfall point. One of the main changes will be the reduction of the geometric compression ratio from 18:1 to 16:1. This measure, designed to reduce emissions and make thermal performance more uniform between manufacturers, represents an enormous technical challenge. Lower compression means lower initial internal pressure and, in theory, lower combustion efficiency. For most teams, this means having to redesign their engines to adapt to an environment less favorable to generating explosive power. But Ferrari has interpreted it from another perspective, as an opportunity to redefine efficiency through thermal control. Steel cylinder heads, by withstanding much higher temperatures and pressures than aluminum cylinder heads, allow the engine to operate closer to the ideal thermodynamic limits. This means that even with lower compression, Ferrari can get more useful work per combustion cycle than its rivals. In essence, they are aiming for superior energy efficiency, allowing them to consume less fuel, maintain higher temperatures, and generate greater power without breaking the restrictions imposed by the FIA. But like everything in F1, every advantage has its counterweight. The big risk Ferrari faces is weight. The cylinder heads are located on top of the engine, making them a critical factor for the car's center of gravity. A heavier engine, although more powerful, can compromise the overall balance of the car. It can affect braking stability, traction in slow corners, and general agility on technical circuits. Furthermore, everything above the center of mass acts as an amplifier of lateral inertia, and that can have unpredictable consequences in extreme maneuvers. The 2026 season will be a watershed, because this engine is not just another improvement, it's a before and after. If it works, it will mark the beginning of a new stage in power unit design. It will push the rest of the manufacturers to rethink their fundamentals. And Ferrari, after more than a decade of frustrations, could regain its natural role as the technical standard bearer of the category. But if he fails, it won't just be another defeat. It will be confirmation that even when Ferrari tries to be radical, its bets end up devouring themselves. It would be a blow not only sporting but also cultural. A reaffirmation that the Scuderia, no matter how much history it has, is still trapped between its myth and its reality. All of this makes the 2026 season something bigger than a competitive campaign. It will be the final judgment of a philosophy, to a team that has dared to look beyond the accepted limits, and to an engine that, without having yet taken an official lap on the track, has already left an indelible mark on the technical conversation in the paddock. Meanwhile, the rest of the world watches. Rival engineers, specialized journalists, former drivers, and fans who have viewed each era of this category with skepticism and amazement. Everyone waits. They all ask the same thing. Will steel be the metal of the future, or the weight that sinks once again Ferrari's dream? Leave me in the comments what you think about all this.